You see them everywhere, right? Electric cars, massive wind turbines, solar panels on every roof. We see the green future taking shape. But have you ever stopped to wonder what's actually inside them? What are the invisible ingredients making it all work?
Well, the answer comes down to a special group of materials, things called critical minerals and rare earths. They are absolutely essential for our modern tech. But as we're going to see in this explainer, they're also shaping up to be one of the biggest bottlenecks to our future.
So, here's our game plan. First, we'll get a handle on what these materials actually are. Then, we'll look at the incredible boom in demand. After that, we dive into the huge supply bottleneck, figure out the risks it creates, and finally, check out the global race to find a solution.
Okay, first things first. What exactly are we talking about here? Let's make sure we've got the key terms down.
You know, it's funny, the name rare earths is actually pretty misleading. Some of these elements, they're more common in the Earth's crust than stuff like copper or lead. The rare part isn't about scarcity, it's about concentration. They're just not often found in clumps big enough to make mining economical. And that one little detail is a huge part of the story.
And that challenge is getting bigger by the day, because our hunger for these materials is just exploding. Let's take a look at how this demand is completely reshaping global markets.
Just get a load of this. According to the International Energy Agency, the demand for lithium shot up by nearly 30%. Not over a decade, in a single year. And it's almost all driven by the energy sector. This isn't your typical steady growth. This is a rocket launch.
And this right here shows you one of the biggest reasons why an electric vehicle needs something like 3 to 4 times more rare earth elements than your standard gas-powered car. And most of that is for the super powerful, lightweight magnets that make the motors spin. So every single EV that rolls off the line just cranks up our need for these materials.
So yeah, it's all about the magnets. These high-performance magnets are the single biggest thing driving the entire rare earth market, making up over 40% of all demand. These tiny but incredibly mighty components are at the heart of everything: EVs, wind turbines, robotics, even the phone in your pocket. Okay, so demand is through the roof. But what about supply? Can we get enough of this stuff? Well, this is where our story takes a really sharp turn. Let's talk about the great supply bottleneck. Getting from a rock in the ground to a finished magnet isn't a walk in the park. It's a long, pretty complex journey. You start with mining, then you concentrate the ore, then you do all this complex chemical processing. But there's one step in here that's way, way harder than all the rest.
And that's the critical bottleneck: separation and refining. This is the stage where you have to take all 17 of these rare earth elements, which are all chemically super similar, and painstakingly pull them apart into ultra-pure materials. It's tough, it's expensive, and right now, around 90% of it happens in just one country.
And get this, it's not just a rare earths problem. For a lot of the critical minerals you need for batteries, we're talking cobalt, graphite, nickel, it's the exact same story. One single country pretty much dominates the all-important refining stage, and that creates a massive choke point for the entire global supply chain.
So, what happens when a whole global system depends so heavily on just 1 or 2 places for something so important? Let's unpack the real-world consequences of all this concentration.
Check this out. The IEA ran the numbers, and what they found is pretty eye-opening. On paper, it looks like we'll have plenty of these minerals over the next decade. But, and this is a huge but, if you take the single largest supplier out of the picture, the remaining supply can only meet about half of the world's demand. The whole system is balanced on a knife's edge.
And don't think this is just some what-if scenario. This is real. Over the last couple of years, we've seen countries increasingly use export controls on these exact minerals as a strategic tool. The vulnerability is there, and it's actively being tested.
So, why should you care? Well, here's the bottom line. A serious, long-term supply disruption could jack up the price of an EV battery pack by 40 to 50%. That's a huge deal. This risk has a direct line to our wallets, and it could seriously slow down the entire green transition.
So, as you can imagine, this situation has kicked off a global search for security. Let's move to our final section and see how the world is racing to build supply chains that are a lot more resilient. You better believe governments are paying attention. We're seeing this huge wave of major policy initiatives. You've got the EU's Critical Raw Materials Act, the Inflation Reduction Act in the US. All of them are pouring money into new mines, new processing facilities, and building up strategic stockpiles. It's all about diversifying their supplies.
But here's the thing, the solution isn't just about digging more holes in the ground. A massive part of the future here is creating what's called a circular economy, which means recovering these super valuable materials from old products when they're done.
And we're not talking about some small niche concept anymore. The market for just rare earth recycling is growing at a staggering compound annual rate of about 25%. That's one of the fastest growing parts of the entire materials industry. It's huge.
I mean, listen to how this market report sums it up. It says recycling is becoming a strategic pillar of resource security. So it's not just a nice thing to do for the environment anymore, it's become a matter of national and economic security.
And what's really cool is the sheer amount of innovation that's making this possible. We're talking about AI that makes finding new deposits way more efficient, new hydrogen-based processes that can recycle magnets with over 90% yield, even using biological organisms to pull minerals out of old mine waste. Technology is opening up totally new ways to get these materials.
So here's the big takeaway. We are smack in the middle of a profound shift. The resources that built the 20th century, like oil, are not the ones that are going to power the 21st. And as we've seen, building that new foundation isn't just about digging, it's about innovating, and it's about recycling. Which leaves us with the final, really big question. Will the circular economy for minerals become as essential to this century as oil was to the last?